Hello and welcome to the AIM webinar series. Today's session is Amtrak improves safety, efficiency, and inventory accuracy with RFID-enabled life cycle management system. And today's speaker is Anurag Kulshrestha. First, a little bit about AIM. AIM is the Industry Association for Automatic Identification and Data Capture Technologies. We serve as a hub for quality resources covering all types of barcode, RFID, and mobile computing information. We also foster new auto ID innovations that stimulate market growth. We encourage you to get involved. If you would like additional information, reach out to us at info@aimglobal.org. It is the policy of AIM to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. And then a few other housekeeping notes. All registrants are muted upon entering the webinar, but we still want you to participate. To send a question, select the Q&A icon at the bottom of the screen. We'll get to as many questions as possible at the end of the presentation. Also, a recording of the webinar will be available in the coming days to those that have registered. All right, and today we are joined by Anu Kulshrestha, the President and CEO of Enantix. I'll turn it over to you, Anu.
Yes. Thanks, Bethany. Thanks, AIM, for giving me this opportunity. I'm going to share my screen, if that's fine with you. Okay. So who we are? We are Enantix. We are a Michigan-based company. We are IoT systems integrator and independent software vendor. And we have been in Michigan since 2009. I started this company at that point in time. And recently, last year, we were selected by Amtrak as their RFID solution provider. And it was lengthy, competitive solicitation process. And so we are bringing the complete solution. We are acting as a one-stop RFID solution provider. And where we are bringing the hardware, we are integrating the hardware. We have our own software, which we are heavily customizing for Amtrak. And as well as we are providing different kind of professional services, and we are integrating their SAP system, Maximo, and the ArcGIS systems for now. So this webinar is regarding the railroad operators and their operations and what they can do with RFID. So if you see here, I have created two kind of columns. We have the freight railroads and we have the passenger railroads. And Amtrak is one of the largest passenger railroad operator in the United States, and there are so many others. So there's some fun fact. We have close to 160,000 miles of railroad tracks in the United States, and Amtrak is again is a passenger railroad company, so they are operating on close to 21,000 miles of tracks, right? And Amtrak maintains their inventory throughout the United States. They have the different kind of warehouses and facilities, but the large ones are, they call the facilities, and they could be huge. They could be like a multi-million-dollar operations, as well as they can have quite large, size and area. And again, I was just Googling last night, and I found that they were 24 billion plus asset valuation company. So it's all about the material management, right? So they store, Amtrak is storing many of their assets in their secure warehouses, but some assets are quite large. They cannot store inside the warehouse. So for example, I'm picking one case in point, which is the CWR, which is a continuous welded rail. So it is 1,600 foot long, which is 1/3 of a mile, and it is quite large, and its weight is approximately 70,000 pounds. So they are not storing indoor, rather it is outdoor, and at the same time, most of the time it is on the right of way alongside of the track where they have to be installed or they have to be repaired. And the different machines are there, like we call the track laying machine. This is like a large train with lots of machine, and it is close to a 1/4 mile long, right? So it's all about inventory, and it's not just Amtrak is not a small organization. So it's not that everything has to be tracked indoor. They are dealing with lots of vendors, their contractors, suppliers, because Amtrak, by its nature, is not manufacturing that track. or the rail itself. Some other supplier is manufacturing them. And same thing you would see when I move forward to the next screen. Some different assets are being manufactured by different suppliers. So Amtrak had this different kind of goals in mind, and they were trying to achieve. And it is a multi-million dollar contract as a multi-year contract, what we have with Amtrak. And it's going to happen in phases or number of years. So this year they had the some reduced budget, so they're going to have the less scope. Last year we did the very lengthy POC, proof of concept, almost 9 months. And once I talk about it, you would see that why it took 9 months to even perform the POC. So a couple of objectives were there in mind, right? One was the visibility in supply chain, not only internal but external too. What supplier is manufacturing for Amtrak, when it is delivering to them, where it is being delivered, where it is being dropped off, when it is being installed, and so on. And thereafter, we have the warranty and the maintenance and repair and quality checks and so on. So different kind of objectives are there. So you can see most of these objectives are also aligned with few other use cases in non-railroad industry too, right? So such as supply visibility, you're looking at in the whole supply chain, you're looking for the definitely tracking, tracing, inventory. At the same time, we have the different type of regulatory compliances regarding the railroad in the United States. I have listed few of them. And once everything is there, right, at the end, they also very, keen to find out for the warranty management. So let's say some asset was delivered to them, it is supposed to last 30 years, 40 years, 10 years. So is it, if it is degrading, it's not performing well, they have to, the warranty will kick in and they have to get back to the supplier or manufacturer. And there are like millions of assets are out there. And it's, you can think it's a very large operation. So managing them, within the paper form or the SAP or the Maximo itself was not good enough. That's where the RFID is coming in. So what are the key challenges in this railroad operator use case, which is not there mostly in many other use cases? So with the railroad, we have the very where the track is there, it is made of steel. You have lots of assets under the train car itself, including the wheels and all. And they all are very dense and high metal environment. And we cannot install the RFID antennas at the front of the engine or at the tail side of it because of different other reasons. So only opportunity we had to install under the car, underneath of the car of the train itself. So if you see, we hardly have the 2 or 3 feet of air gap. And at the same time, the train is moving pretty fast. In some cases, it's more than 100 miles an hour. To read a tag at that fast moving space and in very highly dense metal environment was a very key challenge. So we took several months in testing the different types of antennas, different types of tags, different kind of orientations when we are testing. So if you see here, this is the one POC proof of concept phase. And at the same time, I want to make it very clear, I'm not sharing any proprietary or any confidential data from Amtrak. I have picked most of the images from the Google, which are publicly available, and still trying to show you something without compromising our confidentiality with Amtrak. So on the right-hand side image here, you can see that we have installed a structure, and on that structure, we have 4 RFID antennas. And other thing called the concrete tie. This is another asset. So the very first phase, what Amtrak wanted to take on was the difficult assets to track. One was the track itself, and second was the concrete tie. And this concrete tie on the left image you are looking at, I'm showing you the mold. It's an open mold. It had the 24 metal bars going through it for structural strength. And on the right-hand side, I'm showing you the array of all the molds. So we have 6 rows and we have the almost 50 columns. So 300 at one side and 300 other sides at a time. 600 concrete ties can be molded, can be manufactured. And so we have the lots of metal inside. We also have the large metal clamps on the top of the concrete tie. So what you're looking at the mold, it is upside down. And where this green dot we have, that's where we are putting the RFID tag. And the total length is more than 8 feet and it's 9 inches tall and 11 inches wide. And why it took that many time? Because first we have to qualify the right RFID tag, which will work in this environment. And once we put this RFID tag of chosen RFID tags rather in the starting, and it takes close to a week to cure this concrete tie. And thereafter, so we have to test there, but that's one set of a test. So real test happens when they get loaded to the carriage car and they get installed. And while we are installing it, we are scanning the RFID tag. And at the same time, second time it happens when the train is moving pretty fast, is it able to scan it or not? So that's why each time we do any iteration, it takes more than a month, at least sometime 2 or 3 months to go through the cycle. So we do not have the luxury to just keep changing the RFID tag or antenna, the orientations or the placement and so on, because the time we have to have that much time to test it out properly. So this is other asset, which we call the CWR, continuous welded rail. So each is, we call the stick, and that CWR stick is 320 feet in length. And these sticks get thermite welded. And the temperature that time could be 2200 degree rather, Fahrenheit, right? So making the 1600 feet CWR string. And further in the field, when they're being installed, they again get, welded at this, special machines are there for that, right? And since this track itself could be either side be rotated and can be installed on the left-hand side and right-hand side. So what we are doing on the leftmost image, I'm trying to depict here, we are putting the 2 RFID tags on both sides. And this is again a special RFID tag because lots of metal impact will happen, heavy metal impact. I told you this weight of the whole CWR string is close to 70,000 pounds. So we have to make sure that the tag can live the impacts, and at the same time, the weather, the rain, and bunch of other environmental conditions would be there. And plus, we cannot have very large tag, reason being is the wheels are on the top and the clamps at the bottom of the track. So again, we have gone through lengthy exercise and we have tested 40 plus different kind of tag from different OEMs from different countries. And we have selected what gonna work best for them, right? So in a typical year, close to 100,000 to 250,000 concrete ties are being laid, being installed, and close to 100 to 150 miles of CWRs are being, installed or repaired in a typical year. And it depends upon, what kind of funds they have, what kind of maintenance needs they have it, and many other infra projects going on, and why they use the CWR lately in all over the world, because it gives the better ride instead of the jolting or, putting the nuts the old way people used to do it. Okay. So here, I'm just taking a picture here. You can see that in the middle where my mouse is, we have one RFID tag, and once it gets stuck, it becomes like a part of it. You cannot peel it off, or it's very sturdy over there, right? And at the same time, if you see where my cursor is, we are seeing one antenna. So that's what the train is passing by. And so we have the tag embedded inside the concrete tie. It's inside the concrete, you cannot see it, but it is there. And on the track, it is exposed to the environment. And when the RFID antenna is moving along with the train, it has to scan the concrete tie as well as the tag on the CWR. So here, you are seeing on the right-hand side, this is the TLM machine, track laying machine. So what it does, it removes the older track and it puts the new concrete tie as well as the new rail track, right, CWR. And on the left-hand side, you are seeing this is just a one arrangement. We have the different kind of arrangements for different kind of the trains. We have the Geo car, we have the TLM, different kind of train cars are there. So we have the different arrangements depending at what speed they move. So it's not just a one universal set which is going to work everywhere, right? So here you are looking on the left-hand side, you can see a one structure we have built under the train car, and we have few antennas which are in the middle, which is trying to read what's in the concrete tie and what are facing toward the track are trying to read the RFID tag on the CWR. And even this white, the PVC kind of pipe you're looking at, that's also the one wire antenna we have it. It is almost a meter long, 3 foot plus. And what we have done it, we have installed the RFID reader inside. And so, again, in different arrangements, sometimes we have only one RFID reader, sometimes we have 4 RFID readers inside, depends what all we are reading. And we have attached the 5G router, and we have put the AT&T and Verizon SIMs in them, and also have the 4x4 and MIMO and 6x6 MIMO Wi-Fi, as well as the GPS antenna part of it. And GPS antenna and this 5G antenna, you can call it, is installed on the rooftop of the car. So here I'm showing you one use case where we had only a single RFID reader installed. And this is at the POC phase. At this present time, we are building a nice cage around it and sophisticated professional looking manner. So nothing is open, but this is while we were testing it. And on the right hand side, I'm showing you the 5G antenna, which is providing the fast internet to us, GPS location, and the Wi-Fi. In some cases, we have to do the testing. That's why we need the Wi-Fi as well. Okay. And here I'm presenting you without compromising too much secret sauce, what is the high-level solution architecture we have built it for them. So many devices are there, right? Different kind of devices we have. We have the edge devices, and why we brought the edge devices. What if the connectivity, internet connectivity between the train and our server breaks, right? So we are holding the data on the edge device, and it keep checking every minute whether the internet connectivity is there or not. If it finds it, it is going to upload the data to our server. And we have, again, Amtrak is regarding lots of security. So different kind of gateways are there, which we have to go through it. And all the data, we are encrypting it. The data, even the EBC data, is getting encrypted. And then we have the SSL as well. And that's where it is being passed through the different secured gateways and then hits the server. And on server is highly containerized, which can work, again, on any operating platform. It could be a Red Hat Linux, it could be Ubuntu, it could be Windows Server, it could go in the AWS, it can go in Azure. For example, for Amtrak, we are utilizing the AWS, and we are using the ECR, Elastic Container Services, and Elastic Container Repositories, and is highly containerized solutions which can scale horizontally and vertically. And they have the different external applications where SAP, ArcGIS, Maxima, and all, that's where other related data is there. So we are tying up the RFID EPC data along with some other details. And when we get the data from the field RFID reads, not only we get the RFID read, we also get the latitude, longitude, elevation, speed, northing, some geospatial elements along with it. So the different ways Amtrak is trying to approach this project. Very first thing is when it is being laid, what time, which asset was laid on the track, for example, right? And thereafter, the other train will run on monthly basis for the quality checks and so on. It has the different kind of ground penetrating radars, cameras, bunch of other equipments are installed under the car. And all this data is being read again and again. And we have the very sophisticated, the web application as well as the mobile handheld readers are there too. And we are not only containing within the ecosystem of internal Amtrak, rather we are providing some solution components to their vendors and suppliers as well. So when they are supplying or sending all these assets such as CWR or Concrete-Ties, they're going to do some activity. So right from the source itself, the birth of the RFID tag takes place in our system, right? And then we track throughout the system. So very first phase was all about the CWR and the Concrete-Tie. So these are the assets spread throughout the United States. They are in the field right now. Before this RFID project, lots of manual testing, manual QA/QC, manual counting was going on, and people were walking several miles along the track, because alongside of the track, the right of way of Amtrak, these assets are lying there, right? So somebody has to find out, let's say they ordered the 5,000 tracks, whether 5,000 really came it. Let's say 500 has to go to Michigan, 200 has to go to Pennsylvania, 700 has to go to Wisconsin, and so on. So they are properly delivered, and are they at the right place where they want it? So lots of supply chain issues is gonna handle it. So in the first phase, again, I'm repeating myself, Amtrak was handling the CWR as well as the Concrete-Tie. But they got, believe me, several thousands of types of assets, which they want to tackle in the next phase and the following phases in next couple of years. Like indoor warehouses, some high valued items, or it could be HVAC system, it could be their radio system, there could be the toilet assemblies, the chairs, and many kind of assets are out there, recorders and so on, which they want to first track it, and thereafter the warranty process. So it will be the large ecosystem with the RFID, and later on we will also bring some sort of sensor RFID tag or active sensor tags, because not only where the things are, yes, they want to know the location awareness, but as well as the environmental awareness. Is it vibrating? How hot it is it gonna, is it creating a strain? Is gonna break? And all of those things gonna happen, right? So it started as a RFID solution, but it will turn into a true IoT solution. So I have given it some of these, details about the project. What we are already in the second phase and second year of Amtrak project, and as I mentioned earlier, it's a multi-year, and we have done lots of learning in the process, and we just keep making the course corrections, keep making the solutions differently, and at the same time we are changing the processes, procedures, and at the end the solution behaves that way. So I'm going to stop for a while and listen to questions and comments, Bethany. And I'll stop sharing myself.
All right, so we'll get started with some questions here. All right, and then one question we have here is, why is RFID the technology that's right for this project?
Yes.
Or what differentiates it from other solutions?
Yes. So as you know, in IoT, right, we have many technologies: RFID phone, BLE, Bluetooth Low Energy, long range wide area network, ultra wideband, and so on. So very first thing is these assets are in the field, and they are spread throughout the United States, and US is a large country. So nobody is gonna change the battery even after 5 years or so, right? And more than that, it is gonna go through the extreme weather condition. It will be hot in some states, it will be cold in some states in the winter. And these, like say, Concrete-Tie itself, it's supposed to last 40 years, 40 years, maybe let's say 20 years, 30 years, right? When they're doing the maintenance and repair. No other technology at this point which can behave like a passive UHF RFID tags, which can last, several decades and still be operational. And so for that reason, the battery less or the passive UHF RFID technology was selected over the active RFID technologies.
All right, and then another question that we have here is, how do you handle the case that CWR and maintenance will be cut and small parts replaced? Further, this means that you have serialized tracking of each and every CWR. What has been the reasoning to start with CWR and not with highly safety relevant components such as switches, crossing, frogs, or expansion devices?
So CWR, two things. It is one of the costliest asset they have it. And second thing is it is hard to track the count because it is, if you think about the 21,000 plus miles are there, right? And so many repairs are happening, replacements are happening, and so on. So many assets are there. And right now, there was no technology. If you just put a sticker and a QR code, barcode is not good enough with the weather elements they are facing it. So what we do, even though CWR is a 1,600 feet, it is it is made of the 5 CWR sticks, which is the 320 feet in length. So on the 320 feet length, we are putting the RFID tag. Yes, sometimes they get cut or sometimes they get welded. Then the new RFID tag come on them, right? So we register at the same time what is being cut, what is being replaced, and sometimes they cut a piece and they transport to some other location, right? So all this, the key location points and the sensor location point, RFID tagging, we are taking account and we are registering in the system.
Thank you for that. And if there's any more questions, you can enter them through the Q&A selection at the bottom of the screen. We'll just wait a little, see if there's any other questions coming through. All right, another question we have here is, how do you handle errors of type 1, something is not red which should be red, and errors type 2, something which is not there is red? In other words, how is the process stability kept high enough?
Yes. So we call it like, I'm going to answer the second question first, which is the registered versus unregistered. So we know what all the RFID tags which we have supplied to the vendors, and they are sitting in our database. So anything which is not registered in our system is not being read. Anything is not coming from our readers. We know the max, and we have again white IPs on them, and they're encrypted. If the data is not ours, it is being discarded right at the edge itself. It's not even entering into our system, right? Yes. So we are doing the heavy testing. What if something is not being read? And that's why I'm talking about somewhere we have put the 4 RFID readers, different kind of antennas. They are spread throughout the car, under the car of the train itself, right? And so I can give you, I was looking at one read on the 12th of March. It was read at 121 miles per hour plus speed. So at that speed, 121 miles, and these antennas are installed under the train of the car and the track is there. So at that speed, we are able to read it. And as we are gonna install these solutions more and more in different places, we're gonna have all these learnings as well. And we are creating different kind of extensive use cases. We are trying to find out what the failure points are, or what and how we can either change the process or change the installation or change the component. So those things will be always a learning curve. Yes, it is a science. It's not a perfect that, okay, when it is running, yes, something can be missed, but we are quite aware of it. And so far, we have made the great stride in picking up all the tags what we wanted.
All right. So I think we'll move on to, if you have any other questions for Anu, you can reach out through the information listed on the screen. Actually, there is one other question that just came up. Let me get to that real quick.
Mhm.
So the person said, thank you very much. Lastly, in many European countries, concrete bears sleepers are marked with RFID tags on the shoulders and not in the dead center. This to also provide orientation information. What has been the reason to place RFID tags in the center? And further, are you also looking into dual tags, NFC type 5 plus UHF and one tag?
So yes, when we were thinking about where to place the RFID tag, right? And we thought about, and we did, we put on the both end, we put on the center, sides, all possible thing you can think about it. First thing was um, the structural strength, because we are not embedding outside. Why we are not embedding outside? When you see their operation, when they moving and people are installing sometimes they get the very harsh rub against each other, and anything on the surface will be knocked out immediately. And once you have been in the field, you will notice that. So nothing can be attached on the surface because it is going through the extreme operational conditions. So on the side, what we have the 24 those metal rebars or metal strings are coming out. And if we place any tag which is bigger in size, then it may compromise the structural strength. And so we cannot compromise the structural strength. That's why those side ones were knocked out by their material management and engineering team, right? And only thing we were given very thin, like you can think about almost a sticker kind of a tag which is buried inside the on metal kind of tag. That is on the there, and that's where we have the least amount of the metal. And when the train is running like that, right? The antenna over it, and sometimes it is at the angle or flat and different angles. So that's where we are reading it, not on the side. And we wanted to install on the side. Still, we are talking to the team, and we have come up with a different kind of antennas. And so tags are there which can be installed on the side. And other operational issue was we cannot slow down their process of manufacturing, because these people start, even though something takes even let's say 5 seconds, is too much of a time because hundreds of thousands is manufacturing of the assets are happening. So we cannot take the time. We cannot tell the labor over there in this particular angle or orientation, this RFID. So it has to work like a very dumb proof manner where people can just throw the RFID tag in the middle and it will work, because on the side we have to hang it on the metal string, and that's why sometimes it was laying flat and so on, defeating the purpose.
Thank you for all those questions. As I was saying before, if you have any other questions for Anu, you can reach out through the information that we have listed on the screen here. If you have any questions regarding AIM and our initiatives, we have our email address info@aimglobal.org if you'd like to reach out.
Yeah,
And
if
thank you so
anybody has
much.
any questions, as Bethany said, yeah, feel free to reach out to me or her, and we can provide further answers.
Thank you so much for joining me today, Anu.
Yep. Thanks, Bethany. Have a good day.
Have a good day, everyone.
Yep. Bye for now.